Hi there. In this video I'm going to be looking at this wireless transmitter-receiver combo found on these two boards. The goal is simple, to transmit a value between two Arduinos using these two boards. A setup like this could be used to control an RC car. Let's look at the transmitter hardware. The interface between the Arduino and the transmitter board is very simple. 5 volts in red, ground in black, and a signal wire in yellow are needed. The data being sent is the position of a small potentiometer hooked up to the Arduino. Now onto the transmitter software. First, the data is read using the analog read function in the Arduino library. The data is then encoded as a frequency. This is done to allow the data to be transmitted using the tone function of the Arduino library. The tone function takes a frequency from 31 Hz to 65 kHz as a parameter and generates a 50% duty cycle square wave output on a specified pin, which is supplied as the second parameter to the tone function. The range of possible values read using analog read are from 0 to 1023. This range is mapped to a frequency range of 5000 to 10,000 Hz using the map function. This frequency range is chosen arbitrarily, keeping in mind the restrictions of the inputs of the tone function. The Arduino loops through the steps of reading from the analog pin, mapping the data across, and then updating the tone function. Now onto the receiver hardware. The interface is very similar to that of the transmitter. The main difference is the use of a pull-down resistor on the signal wire. This works to stabilize the signal pin when there is no transmitter present. Without the pull-down resistor, the pin would have a tendency to float when there is no transmitter active in the area. The result of the transmission is scaled to be shown as the intensity of an LED hooked up to the Arduino through a pin that supports PWM, or pulse width modulation. The correct operation of the transmitter receiver can be tested using an oscilloscope. The scope leads are connected to the ground shared by the receiving Arduino and the receiver board, and to the signal wire coming from the receiver board. The scope displays the data that is being transmitted. Moving the variable resistor creates a notable change in the scope reading. One can easily note the change in the frequency of what the receiver is picking up. The board is therefore working as expected. Let's look at the program of the receiving Arduino. Since the data is encoded as a frequency when it is sent, it can be decoded using the pulse-in function in the Arduino library. Due to the fact that the tone generated is a square wave with 50% duty cycle, the length of a high pulse generated by the tone function will be equal to 1 divided by 2 times the frequency, or in other words, half of the period of the wave. The pulse-in function measures exactly this quantity, returning the number of microseconds the high pulse lasted. So using the described relation, the frequency being sent can be determined. In reality, the range of pulse durations received varies slightly from the theoretical values expected, but this can be solved quite simply by using extreme value checks in the receiver program. Another feature of this program is a smoothing buffer. The average of all the values in the buffer is used as the filtered output. The filtered output is then mapped to the range from 0 to 255 so that it can be displayed as the intensity of the LED using the analog write function. This analog write function is essentially a PWM output whose acceptable inputs range from 0 to 255. The general operation of the setup is quite satisfactory. There is some delay in the response time of the system, most likely as a result of the circular buffer. Making the system a bit more suitable for RC car would simply involve changing the input potentiometer for one mounted into a more suitable handset and changing the LED to a servo motor. Thank you for watching, and for more videos like this, please subscribe. And if you have any questions, please feel free to ask them in the comments below. Thanks again, and see you later.